Hello, and welcome to Backer Breaks It Down. In this episode, we are going to find exact values of trig functions at special angles, just like Paige here, who wants to know what is the cosine of 60 degrees. It's 1/2, by the way. But 60 degrees would be like what I mean by special angles. Basically, we're talking like angles that are that would have one of those special right triangles as their reference angle. Remember those from geometry? It was like 30, 45, 60, the 30, 60, 90s, 45, 45, 90s. Yeah, those. Yes, we get to use those again. Okay. But I want you to realize you already have quite a bit of knowledge that's necessary for doing such a problem. Okay. Because basically it all comes down to the angle. So this angle, -7 pi over 6. What do you know about an angle with this measure? Just tell me everything you know regarding this measure. Yeah, so it's like in radians, and most of us are not like radian, like we're just not comfortable with radians. So we can like totally convert this into degrees. And so yes, that would be -210 degrees. Yeah, I agree. Like negative angle measures are kind of like strange to me. So we can totally go coterminal. And so if we do that, we get 150. We could sketch it, like here's my my plane. Let me get a different color. So I have my like initial side, and then I would want to go like counterclockwise. And so it would look like this. So it'd be in quadrant 2. Did somebody just say something about a reference angle? So that'd be this angle here, formed by the x-axis and that terminal side. So it has a reference angle of 30 degrees. Wow. So you know quite a bit about this angle. Okay. And that's like, really, that's what you need to know. You want to know, like, where is it located? Like, what quadrant could you draw a reference triangle in? And we could totally draw a reference triangle in quadrant 2. We even know the reference angle is 30. So then what do we do with this? Well, a 30-degree like reference triangle would look like this. Okay, so opposite the 30 degrees is a side that measures 1. For all of our reference triangles, I like to keep it simple and use a hypotenuse of 2, and then do the math. The other side would be the square root of 3. So I can like totally draw this in quadrant 2, right? Because we determined that that one angle was 30 degrees. Opposite the 30 is 1. The hypotenuse is always 2. And the third side here is the square root of 3. And then, like I always say, watch your signs. Like, we're in quadrant 2, so what's negative here? What's negative here is the x value. In a reference triangle is all you need to go and find the values of your trig functions. So, like, believe it or not, we are currently working on number 6 in our notes. And number 6 wants us to find the tangent of our -7 pi over 6 angle. And so we did all like the necessary pre-work, I guess, because we converted it to degrees, we went coterminal, we found where that angle would lie, and it would lie in quadrant 2. We found our reference angle is 30 degrees. We made this great sketch, okay? And so all that's left now is to write down what is tangent. And tangent's the opposite over the adjacent. So tangent would be 1 over negative square root of 3. And then we'd have to rationalize it. So we'd multiply the top and the bottom by the square root of 3. And then finally, we can say what tangent of -7 pi over 6 is. And it's negative square root of 3 over 3. Like, that's the exact value of our trig function. Okay. And so basically, look at the angle And ultimately, what you want to know about this angle is what quadrant will it lie? And what's the reference angle? 30, 45, or 60 degrees. And then once you create that sketch, it's just a matter of writing the ratio. Okay, but the angle, dealing with the angle is the biggest part. So that was number 6. So let's take a look at number 4. 4 is cosine of 765 degrees. So think about that 765. It's too big, right? So I should subtract 360. And when I subtract 360, I'm going coterminal, I get 405. And that's still a little too big for me. So I'm going to subtract 360 again, because sometimes we have to go around more than once, right? And I get 45 degrees. So now I'm feeling good. I'm 45 degrees is in quadrant 1. And quadrant 1 is perfect. Sorry, that's my dog. 45 degrees is perfect because it's in quadrant 1, and so the angle and the reference angle have the same measure. So then I can label the sides of my triangle accordingly. So opposite the 45 degrees is the square root of 2. The hypotenuse is always 2. Fill in the other side. Take a moment, check your signs. Here in quadrant 1, everything is positive. So then finally, write your ratio. Cosine is adjacent over hypotenuse. So we're looking at the square root of 2 over 2 as our final answer. So if necessary, go coterminal. 660 is a bit too big, so I'm going to go coterminal and subtract 360. So now I'm down to 300, and 300 I feel pretty good about. So now I'm ready to find my reference angle and make my reference triangle. So here I am. I'm going to be in quadrant 4 this time, right? Here in quadrant 4 for that 300-degree angle, that means I would have a 60-degree reference angle. And so now I'm going to label the sides accordingly. So opposite the 60 is the square root of 3. The hypotenuse is always 2. And the third side is 1. Watch your signs. Here in quadrant 4, y is negative. And finally, you're ready to write your trig ratio. We're writing cosecant. Cosecant is the hypotenuse over the opposite. So we're going to have 2 over negative square root of 3, and we are going to rationalize that. So after doing that, we end up with 2 root 3 on top, negative 3 on the bottom. So negative 2 root 3 over 3 is cosecant of 660. We've already done number 6. That's what we started with. So that brings us to number 7, 13 pi over 4. Radians. So I think we should convert that into degrees. And so I'm going to do that, and I get 585 degrees. You think that's too big? I think it's too big as well. I'm not that comfortable with angles that are bigger than 360. So I'm going to go coterminal. Okay, so subtract 360. I get 225. I feel good about 225. I know 225, that would be in quadrant 3, right? And so I do my reference angle math, and I get a reference angle of 45 degrees. So now I'm ready to label my sides accordingly, right? So opposite the 45 is the square root of 2. The hypotenuse is always 2. The other side is also the square root of 2. Watch your signs. Here in quadrant 3, both x and y are negative. So now I'm ready to write my trig ratio. Secant is the ratio of the hypotenuse over the adjacent. So I have 2 over negative root 2. And then I need to rationalize. So I'm going to have to multiply the top and the bottom by the square root of 2. This is going to give me 2 root 2 on top and negative 2 on the bottom. The outside value of 2 over negative 2 can be reduced, and I end up with negative square root of 2 as my exact value. So finding exact values of trig functions can be done the following way. Think about the angle. If it helps, convert it to degrees. If necessary, go coterminal. You want to know what quadrant this angle is in and what its reference angle is. And then you can copy down the sides of your reference triangle. Watch your signs. And then finally, you can write your trig ratio. And that's how Backer breaks it down.